All right, homework handouts out, if you would please, look something like this. And 4 problems, 3 systems, and a word problem that uses the system. Hold those up if you would please, so that I can see that they are completed. You ripped part of it.
Genesis needed to know that Bond was the best.
Huh?
Okay, all right, question mark, all right. And, looks like we had a little trouble on that second one there, so I'll have you help me with that. Let's go and take a look at our handout. Number 1, how did you solve this? Addition or substitution? Kendall?
Addition.
You did the addition method, so that means you lined up like terms, right? So that means you had to rewrite the first equation.
Y plus 5x equals 7.
Well, that's what it already says. How did you rewrite it?
Oh, y plus... I didn't rewrite that one.
Well, if you use the addition method, you needed to line up like terms, right?
Yeah.
Did you rewrite the bottom one?
Yeah.
Oh, okay, so you kept the y plus 5x equals 7. You rewrote the bottom one.
3y plus 4x equals -1.
Okay, good, and there's nothing wrong with that. I'm used to the x, then the y, but it's nothing wrong here as long as they line up. That's the only thing that really matters. From there, Kendall, you multiplied
I multiplied the top by 3.
to get...
3y plus 15x equals 21.
All right, and then, the next thing we should have done...
You cross out the 3 y's.
Well, not yet, because they don't quite cancel, do they? They would actually give us 6y if you added them.
You have to change the sign.
Top or bottom?
Bottom.
Bottom is a smaller number, so that's where I would recommend changing them. This gives us
Cancel.
canceling, right?
And then 11x equals 22.
And therefore x just equals
2.
2. Now if we go back to the original equation, y plus 5x equals 7, because those were nice little numbers. If we plug the 2 in here, Maddie, the 5 times the 2 gives us a, which we subtract to get -3. So our answer should have been 2, -3. Now you could have used substitution, nothing wrong with that. Or there's our answer, 2, -3 using the addition method. How many got that? Either way you solved it. All right, perfect then on that one. Number 2 looks nasty. The 2x thirds minus y sixth equals 3x minus 1/6. And then we had an x plus 1/6 plus a y plus 7/9, all equal to 3. It's just big and ugly and scary, mainly because of the fractions. And Genesis, how do we feel about fractions and equations? We hate them. Or as you said, we hate them. All right, so we hate them. And so because we hate them, we get rid of them. How do we get rid of them? Good, and we're going to look just at the top equation. What is the LCD? 6. So we're going to multiply everything by 6. And in the lower equation, we're going to multiply everything by... We could, that's an awfully big number. Surely there's an easier number that has both 6 and 9 in it. That's true. There's actually something even better, but 36 will work. 18. There we go. Nothing wrong with the other two, by the way, though your calculator may be a little bit more needful if you'd use those bigger numbers, but 18 works. So here the 6 and 3 cancel to get a?
4x.
Well, 2 initially times the 2x does give a 4x, good. And then here the 6's cancel to get is equal to... All right, and then coming along here, there we go, distribute the 3 that we get, 3x plus 3. Good. And then here, nothing cancels, remember it's over 1, so don't cancel to get a 6, instead you multiply to get 54. All right, it's still not great looking. There's some things we want to try to clean up here. For instance, I've got an x on both sides, Michael. That's just not good.
Move the 3x over to leave x.
Minus y equals -1. There we go. And then here, the 3 and the 14 collectively can move over as a -17, so that my bottom equation just becomes
3x plus 2y equals 37.
There we go. So there's my top equation, there's my bottom equation. We're kind of ignoring the mess that lies between them. And at this point, we've got a choice, addition, substitution. Which one do we want to go with, Audrey?
Addition.
I go with the addition. Everything's lined up, and if I just multiply the top by
3.
Well, you could multiply the top by a 3 and then change some signs, but I'm like looking at the y's and they already look like they almost cancel if we just multiplied a 2, but we'll go with the 3. All right, so we got a 3x, a 3y, and a negative 3, and then change the signs in that same top equation. So negative 3x now cancels. Here we get equals 40. 5y equals 40, and so y is equal to 8. 5y equals 40, so y is equal to 8. Going back, we just a moment ago had x minus y equals negative 1. If I plug the 8 in right here, x minus 8 equals negative 1. What is x? 7. And there's our answer, 7, 8. How many had 7, 8 for the second one? Okay, fewer of us that time. Questions? Now, Genesis had a little bit of trouble with it there initially. Questions on this? All right. Michael, Audrey, any questions? I got it right. Oh, you did get it right. Just didn't see him. Fractions, okay. Did you find where in the work we made a mistake? Not really sure? Okay. Ideally, you find mistakes. That's kind of the objective there. Then number 3 was an interesting one. And we looked at this at the end of the hour yesterday. We're going to work on more of these here in just a moment. But here's one time, in fact, one of the only times I don't want to multiply everything by the LCD. Because here the LCD would be what, Brandon? XY. If I multiply everything by XY, I mean, it works out great. Cancel the X, then cancel the Y. But then at the tail end, we're going to be left with XYs. And that's going to be a real problem for us. So I said what we might do instead is use a process that we call anyone UV substitution. Where we're going to substitute U and V for certain pre-designated equivalences. Class, we said that we're going to allow the letter U to represent what? Anyone? The reciprocal of x, or 1 over x. And V is going to represent, class, 1 over y, the reciprocal of y. So that if I've got a 5 over x, that can become, Brandon, 5u. And 6 over y, class, becomes 6v. And then the 38 doesn't have any u's or v's because there's no x or y in the denominator. Similarly here, my bottom equation, Abby, could become
2u plus 3v equals 17.
And there we go. And now, instead of the big ugly equation, we've got a simpler equation in which we're going to solve first for u and v. Well, I'm going to end up getting u equals something, v equals something. Let's just say, class, u equals, I don't know, 17 halves. It'd be unfortunate, wouldn't it? But let's suppose it equals 17 halves. What would I write for my x value? 2 17ths, because u and v are reciprocals. Let's suppose we got v is equal to negative 8. Well, then, class, what would I write for my y value?
1/8.
Negative 1/8. We would write x and y as the reciprocals of whatever we get for our u, v answers. So let's go and solve the system for u and v first. We're not going to worry about x and y until we get to the very end, then we'll take reciprocals. Back to Brandon. How do we want to solve the system now that we've got it in terms of u and v? All right, so multiply the bottom by 2. All right, so coming over here now. Top equation remains for now 5u plus 6v equals 38. Lower equation.
4u positive 16 equals 24.
All right, and then we need to change the signs. Bottom equation, we'll go ahead and change them there. Cancels, we end up getting
Y equals u equals 4.
u equals 4. We're not ready to convert that back to x yet because we don't need to. We need to go back to the equation, plug the 4 in for u, and solve for v. Genesis coming back to u now. If u is 4, then the 2u is, which I need to move over as a, to get that the 3v is equal to, and therefore v equals 3. Now I'm ready. If u is 4, class, what do I write for my x? 1/4. If v is 3, what do I write for my y? And there are my answers, 1/4 and 1/3. How many had those answers for number 3? Okay, a few of us. The rest of us, do we remember it now that we've seen it work? Does it make sense now? Any questions on the UV substitution? All right, let's take a look at the word problem now. And let's have Maddie, if you'll go ahead and read the problem for us.
How much they invested each year if they received the budget.
Remember these word problems that involve interest, we're going to start essentially with the simple interest formula, which is what, class? I equals PRT. Obviously the I stands for interest. The P, we had some trouble remembering that last time. Do you remember now? Principal, good. R, of course, rate, and T is time is always measured in years. So for the simple interest formula, I equals PRT, the time is measured in years. However, with our charts, remember, we would normally have this times this, equals that. So what we're going to do is we're going to flip it around and say PRT equals I. But since it mentions that annual interest income is $2,240, annual class means 1 year. So since the time is just a 1, P times R times 1 still just equals PR. So remember, we're going to set up a chart this way. And how many did principal times rate equals interest in your chart? All right, so we got two different investments. It doesn't tell me exactly what they are. It just calls one a 12% investment, if you will, and the other a 10% investment. We don't know how much they invested in either. So one of them, class, we'll call X, and the other, since we know that the total, and we have two investments, one's X, the other is. And so we also know the rates. Well, the rates, we also know. We don't know the principal, column X and Y. We do know the rates, but I'm not going to write 12%, class. 0.12, and I'm going to write not 10%, but 0.1 or 0.10 if you wanted to. Doesn't really matter. I'm usually pretty lazy here. So, in 1 year, X dollars invested makes 12% interest. How much interest is earned, class? 0.12x. And Y dollars invested at 10% for 1 year receives how much interest? 0.1y. Now we need to make two equations though, and we're going to use the two major numbers that we were given. $20,000 profit is what got invested. Class, the $20,000 is it's the principal, right? That's the principal. So my first equation should be, Brandon, how many have this as one of your equations? That X dollars plus Y dollars equals 20,000 total dollars invested. Questions? All right, and then interest. That's the $2,240. Well, this is interest and that's interest. What should the second equation be, Michael?
0.12x plus 0.1y equals 2,240.
But I really hate decimals. What should I do with these decimals, Kendall?
You move them 2 places.
Yeah, so if I move it 2 places here, what does this become?
12.
12x. And if I move it 2 places here?
10y.
10y. Didn't leave room for a 0. And if I move it 2 places here?
22,400.
Well, if I move it 2 places, that's actually going to be 2 additional zeros, so 224,000. So careful there, as that could have caused some problems for you. How many got to this point on the system? You got to that point. All right, questions from those who did not. All right, does that make sense now?
Yes.
Okay, and again, using the chart, P times R equals I is going to really help. All right, so I like to solve these by the addition method. And I'm looking at this, I'm saying I could multiply either class by a 10 or by a 12. Either one's fine. Which one's easier? 10. Because 10x, 10y, 200,000, right? But I also want to change the signs across the top where the smaller numbers are. So here the y's will cancel, but when I combine the x's, Audrey, I get 2x. And then here, Audrey, I get 24,000, and so dividing both sides by 2, class, I'll get that x is 12,000, which means apparently the Blackburns invested $12,000 at the 12% rate. Well, they invested how much total, class? 20,000. So if 12,000 was invested here, the remaining, or the $8,000, must have been invested at 10%. And there's the answer we were looking for. $12,000 at 12%, $8,000 at 10%. How many have both of those? Okay, a few of you did. Those who didn't, does it make sense now? Questions on this now? All right, set the handout aside if you would, please. Maybe use the back side of the handout to do some classwork. We will get to some more word problems here in just a few minutes. I want to practice with some more of these rational systems today. as they can cause problems. I want to make sure we're good to go on these as we move forward. Write this down if you would, please, there at your seats, and then solve. X over 2 equals 1 plus y over 3, and 2x minus 1 over 2 minus 3y minus 1 over 3 equals 5/6. I'll have a couple more for you in just a moment, but get started on that one. Once you finish the first one, check your answer. If you're good to go, move on. If you have questions, please ask. How many good to go on that first one? You got it? Everything's good. Questions on that first one? Say, how did you get from there to there? Any questions at all? You in the classroom, tune me out. If you're on YouTube and you were struggling, okay, if you're good on YouTube, tune me out. I'm going to explain it for you just in case there was a question. I think here we're fine. Here, just a matter of moving that -1 over as a +1 to get 6y or 6x minus 6y equals 1, equals 6. I knocked a 6 out of everything. X minus y equals 1. Then multiplied through a negative 2. So I could cancel the negative 2y with now a positive 2y, giving me x equals 4. So that's where that came from. I just couldn't help myself. I had to knock the 6 out. In hindsight, probably would have been quicker just to multiply a 3 through the top. But when I see that many 6s, I've got to knock them out. Does that make sense now?
Yeah, for the 6x negative 6y, I had negative 2y. Because I forgot to multiply it by 3.
Right here, by the way, this is another place where it'd be easy to mess up, right? We cancel to get a negative 2, so as we distribute, it should give a negative 6y, positive 2. If you had a negative 2 here, you'd have ended up with a 10 instead of a 6 at the back end. So that's another easy place to mess up. All right, any other questions, comments on that first one? All right, you're working. I'll erase the first one. Once you're done with the second one, check your answer. Again, if you're good, move on to the third one. If you're not good, see if you can find your mistake or ask a question. I think you were drifting on me there. All right. Have you finished with all of them? Any questions on the second one? How many got the 1/5 negative 2? You're good to go, no problems. All right, questions on this? Is that a hand or holding your head up, Genesis? All right, so you're good now? You figured it out? All right, again, tune me out if you're good, but I didn't want to explain it again. UV substitution becomes 2u minus 8 equals 14, 7u plus 12 equals 29. I figured 14 and 24, the only reason this was 24 was easier, I didn't want to have to multiply 7, because 7 times 14, yeah, it's a big number, it's scary. 3 and 2 is easier, so multiply by 3 and by 2, ended up getting a u was 5, plugged it in, got v as negative a half. At this point, if u is 5, x is the reciprocal. If v is negative a half, y is the reciprocal, negative 2. Okay, questions on that at all? All right, working on the third one then, if you're not already finished. a lot of nods from people. That's a good sign. Take just a moment longer to finish up. All right, let's take a look here. Hopefully, you got your 3v minus 5u equals 2, 25u plus v equals 6. Again, if you wanted to reverse either of these before you even did the uv, that's probably good. You can do it as you copied it down. Just make sure you're careful. You know, wherever there's an x, that's the u. Wherever there's the y, that's the v. Went ahead and reversed this one around, put the negative 5u, then the 3v equals 2. Multiplied by a 5. I was shooting for this here. Honestly, in hindsight, maybe the 3 would have been easier there. I don't know, whatever. Multiplied the 5, got negative 25 equals 15, v equals 10. That allowed the u's to cancel, gave me a 16, v equals 16, so v was 1. Plug that in here to get 25u plus 1 equals 6. 25u then, in other words, equals 5, so u is a fifth. And so if u is a fifth, x is 5. If v is 1, y is, well, 1, because 1 is its own reciprocal. How many had that answer? All right, questions on this? All right, let's take a look at some word problems then. And I'm going to have you work this first one on your own. Take just a couple minutes to set it up and solve, and then after I've given you a minute or two head start, I will put it up on the chalkboard. How many had the correct system? Correct equations? Michael, good to go or fixing something? Okay.
I did 2 instead of 20.
Ah, okay, so just copy error then. I don't know, multiply, top by 6. And change the signs. Gives me a 23y equals 46. Y is 2. What was that? X plus 3y equals 11. So x is 5. So 5 and 2 the numbers. Any questions on that first one? Let's do another one somewhat similar to that one. How many had this system here? X minus y equals 7 and 2x plus 4y equals 26. Then we have y minus x equals 7, and so therefore 2y plus 4x equals 26. You could have had that as long as you reversed both of them, because by first number, that would be the first number in the subtraction. So we could have reversed both of them. It just means your answers here would be opposite. And 6x equals 54. So x will be 9. The difference was 7, right? So 9 minus 2. So 9 and 2 would be our numbers. Good to go on those. Genesis question, face looks puzzled. Did you get the correct system? The x minus y equals 7 and 2x plus 4y equals 26. What was your system?
That's what I got that.
You got that system or you got those answers?
Oh, I just did math wrong. And I got 6y equals 12 as subtracted.
Okay, so you canceled the x's away. So you multiplied a 2 through the top.
Yeah.
So that gave you a 2x minus 2y equals 14. And then you changed the signs across the top. It's a stretch, I know. Cancel the signs across the top, gave you a 6y equals 12. So yeah, y equals 2, that's what I had. So your problem is when you plugged it back in, x minus y equals 7 is where I plugged the 2 in. And then we just add the 2 to the 7 to get the 9.
I plugged the 2 in the 2x plus 4y equals 26.
In this spot?
Well, I did x, so.
Oh, so
Yeah.
you said y is 2, but you plugged it in the x spot. Okay, that was the, so something to watch for then, right?
Yeah.
All right, good. Any other questions on this? All right, back to an interest problem here. Set up the chart, work it through carefully. We'll take a look at it in just a moment. How many had the chart correct? Your principal was x and y, because we don't know either of them. Your rates were 0.03 and 0.01, and so the interest earned in 1 year was 0.03x and 0.01y. Here's the deal. You're going to take your principal, and you're going to add it all together to get total principal. X plus y equals something. You're going to take your interest, and add 0.03x and 0.01y to equal your total interest. Well, what was the total principal, class? $1,200. So therefore your first equation should be x plus y equals 1,200. What was the total interest? $22. So we should get 0.03x plus 0.01y equals 22. Biggest mistake I see is students get these switched. They say total invested plus total invested equals 22 bucks, and the 0.03x and 0.01y equals 1,200. No, other way around. How many had the correct system then? Any questions? All right, finish it out if you haven't already. I know many of you already done. Right there was a 12 and a minus y, but you meant anticipating distributing the 3 made it a 3y too early. Yeah, So you kind of double did a 3 there. All right, questions at all on this now? All right, we'll work on more word problems in the days ahead. Next section of notes, systems of literal equations. Systems of literal equations. You see here on the chalkboard a system of equations, but it involves more letters than just x and y. We expect to see x and y in a system of equations. We don't expect to see m's, n's, or r's. Okay, that's just a little weird, right? Systems of literal equations. First thing you need to write down, you'll only use the elimination method, never substitution. It's just too messy. We're too lazy for that. Technically, arguably, you could use substitution, but it's just such a mess, and we're lazy. We don't do that. So just note you're going to use the elimination method. Also jot down this, that you're really going to need to go through the elimination process twice, because the answer you are going to get for your first variable is going to be so ugly, you are not going to want to plug that in. So you're really just going to do the elimination method twice. Eliminating one variable. The second time you'll eliminate the other variable. Here's my recommendation. When we list our answer, how do we list it? X, then y, correct? So here's my recommendation. The first time through, eliminate the y. That way the first answer you get will be x. The second time through, eliminate x. That way the second answer you get is the y. That's my recommendation. Can you solve it differently? Of course. Just got to be careful plugging in which one. But my recommendation is start by eliminating the y. Anytime there's more letters than just x and y. So here, I want the y's to cancel, but one's an ny and one's a negative 2y. Well, obviously those don't cancel. But I got to make them match, other than I like the fact that the signs are different. Well, how can I make an ny and a 2y match? If I make this a 2ny, and I make this a 2ny, right? For instance, if I have like a 5x and a 7x, how would I get them to match? Multiply this by the 7, and multiply this by the 5, correct? If there's no overlap, right? If this was like a 5 and a 10, okay, just multiply by a 2. But if there's no overlap between like 5 and 7, they're prime to each other, right? They have no common factors, just multiply by the other guy. So here, multiply by the 2 that's here, multiply by the n that's up there, and that'll get me a 2ny and a negative 2ny. What does my top equation become when I multiply 2 by everything, Abby?
2mx plus 2ny equals 10.
I'm going to multiply the bottom equation by the n. What does that become, Brandon?
N squared x minus 2ny equals rn.
Or I'm going to go alphabetical and say nr, though rn does sound better, don't you agree? Just seems like a natural flow to the letters r and n. Registered nurse, for instance. All right, anyway. So we're going to multiply by a 2 and an n. Genesis got it. And of course, when I add the equations together, plus 2ny, negative 2ny, cancel. Right here, though, I'm trying to add a 2mx and an n squared x. Are these like terms? Do you know what we get when we add them? 2mx plus n squared x. That's what we get when we add them. You know what we get when we add a 10 and an nr? 10 plus nr. It's not pretty. I told you it's going to be real ugly. Now here's the deal. You got to solve for x. And it's been a little while since we solved literal equations. But I can't solve for x if there's 2 of them. Which is why normally we combine like terms, but I don't have like terms. They don't combine to a single x. So what was the strategy for literal equations going back about 3 months in your mind?
You pull out the x.
Pull out the x. Factor out the x. You might want to write that in your notes. That one of the key steps then is going to be the factoring step. We're going to factor out, it's a plus sign, not a t. Anyway, we're going to factor out the x, and we're left with in parentheses, class.
10x plus n squared.
Careful, we're factoring out the x.
2m plus n squared.
2m plus n squared. And now, to finish solving for the x, I've got to get rid of the 2m plus n squared. And it's being multiplied. So to get rid of 2m plus n squared, class, I've got to divide both sides by 2m plus n squared. Of course, here it cancels, just leaves me with an x. equals that. Like I told you, your first answer is going to be so ugly, you're not going to want to try to plug that back in. Yeah. So, to solve for y, since I'm not plugging x back in, I'm going to have to resolve the thing again. This time, instead of knocking out the y class, we knock out the x. So, starting from the top here, actually I'm going to go pink chalk because I'm too lazy to recopy it. This time, we need to multiply the top by n and the bottom by m. What does my top equation become when I multiply all the way through by an n? Audrey?
Mx plus n squared y equals 5n.
And when I multiply an m all the way through the bottom, Genesis? Or mr, if we're doing alphabetical order here. Now, unfortunately, my m and x's are not going to cancel, are they? My recommendation here is to almost always put the negative through the bottom. Unless there's a lot of negatives in the top that you want to turn into positives, for your sake, it's generally best just to put the negative through the bottom equation. So I'm going to distribute the negative. Well, this will allow the m and x and negative m and x to cancel. When I add n squared y plus 2my class, I get n squared y plus 2my. And when I subtract or add the negative here, 5n plus a negative mr class, 5n negative mr. Ready to solve for y? It's going to take me 2 steps. First, pull out your y, leaves you within parentheses. N squared plus 2m is equal to 5n minus mr. And then the final step, divide away the n squared plus 2m. And that's the ordinate. 5n minus mr all over n squared plus 2m. It doesn't always happen that you have a common denominator between the abscissa and ordinate. It worked out this time. It won't always be the case. And that is my ugly answer. Now the good news is this seems like it takes forever. There are all kinds of shortcuts tomorrow. We're going to work our way through. For today, I just want to kind of show you the idea of what we're going to be working on more tomorrow with our literal systems. Any questions, though, on what we did here?
Will we have to check?
No, that's the final thing. You never check. You just assume you did it right and hope for the best because, really? Frankly, I haven't been checking the other ones either because lazy. Definitely lazy. Really, really lazy. If I wasn't lazy before, I'm lazy now. Yep, great question. You got any other questions on this? It does force you to pay really good attention to detail, right, and reviews algebraic processes. That's one of the reasons that we practice with the literal systems. You won't have any on your homework this evening, however. If you're watching on YouTube, as usual, you'll find the handout in the description of the video. For those in the class, you'll have the handout to do for homework, which is 6 systems of equations, none of these. Okay, no literal systems on the homework handout, but 6 other systems to solve. We'll take a look at this handout tomorrow as we continue working here. Of course, we'll look at more word problems, but the emphasis tomorrow will be on those literal equations in our systems. Have a wonderful rest of your day, and when the bell rings, you are dismissed.